too. It's been really exciting already. Seeing the light bulbs that have come on and just the kids picking up the habits of the language of math and the conversation. So we're going to go ahead and give you a sneak peek at what math looks like for us now that we are, for starters, this is day 3 in the week, not day 1. And it's year 2 as opposed to year 1. So we have been working on our multiplication cards, 0s, 1s, and 2s this week. I'm actually going to shuffle them up now, so you'll have to pay attention. Are we multiplying? We were doing them by families previously, but now you'll have to think a little bit harder in between flashcards, and we'll do our multiplication cards before we go into our notations. All right, Mason. Not Mason. David.
0 times 6 equals 0.
Good.
0 times 2 times 4 equals
2 groups of 4. Good.
0 times 4 is 4. Wait, 0.
0. Good.
0 times 10 equals 0. 2 times 2 equals 4.
Good.
0 times 14 equals 14.
No, you have 0 groups of 14. How many do you have?
0. 0 times 12 is 0.
Good.
1 times 3 equals 3. 15 times 1 equals
15 times 1 equals?
25.
Nope. 1 group of 15.
1. It's 15.
Yep, it's the identity law. Multiplication identity law. Anything times 1 is itself. So 15 times 1 equals 15.
8 times 1 is 8.
Good.
0 times 15 is 0.
0. 0 groups. It doesn't matter how big the number is. If it's multiplied by 0, it's 0.
2 times 10 equals 20.
Good.
6 times 2 equals
12. Good.
0 times 11 is 0. 0 times 13 equals 0. 1 times 11 equals 11. 1 times 5 equals 5. 1 times 10 is
1 group of 10.
10. 1 times 4 equals 4. 1 times 6 equals 6. 1 times 2 equals 4.
No. 1 group of 2. 1 times 2 equals 2. Say the whole sentence.
1 times 2 equals 2.
Thank you.
1 times 13 is 13.
Y'all are doing really good for mixing
2
it up.
times 7 equals 14. 1 times 7 equals 7. 2 times 5 equals 5. 1 times 9 is 9. 2 times 5 equals 10. He said 2 times 5 equals 5.
2 times 5 equals what?
2 times 5 equals 2.
Nope. 2 groups of 5. Skip count your 5s. 5.
10.
Good. So 2 times 5 equals 10.
0 times 2 equals 2. 0.
0. Leave them alone.
14 times 2 equals...
I don't remember the song, but it's 14,
21.
28. So we multiply 2 times 1 and then 2 times 4. 2, 28. Good. 2 times 14 equals 28.
Okay. 2 times 8 is... It's 16.
Good. Is she right?
Yes.
Good. Right.
2 times 13 equals 26. 0 times 8 equals
0 groups.
0.
0 times 8 equals...
Yeah.
Okay.
0 times 5 equals 0.
Good.
0 times 7 is 1 times 14 equals
2 times.
3 is 6. 0 times 9 equals 0.
Good. Y'all did really good for mixing those up for the first time this week. Let's go ahead and work on our notations. Cards. I should mix these up too. Put that on the same order for 2 days in a row. Let's go the opposite way. What is this? Multiplication. 4 different ways of showing multiplication. We use the X, the dot, the 2 are immediately next to each other, or we use parentheses. Libby?
Plus or minus.
Good.
Parentheses.
It's not parentheses. What does the D stand for?
Dimension.
Good. Equal sign.
Imaginary.
Imaginary wood.
Number. Can you put
That was rude of you to skip your turn, because now you've already given the answer. What is this?
angle brackets?
I'm glad you're excited, but next time I need you to wait. Libby? Do you remember what this one was called, David?
Yes.
Good. What's this one?
Plus.
Plus. And what was this one? Alright, y'all go ahead and open up to page 9. We're going to look at the memoria and arrangement pages today. And we are going to be focusing on our names. The naming, attending, memorizing, expressing, and storytelling skills. So, on this page, who can name something you see?
A line.
You see a line?
And a plane.
So right here, name page I2.
I see a plane. Do you know
Where
what
do you see?
plane is?
Oh, you do see angle brackets. So those are, yep, those ones are angle brackets. Those are
Where's the
braces.
plane?
Very good attending.
No, that's space.
So at the
The
top,
plane is on the side. Yeah, that one.
okay, so here we have the word dimension. Do you guys remember the
The
symbol?
dot.
Yep, our point, our dot. Dimension.
angle.
What was the symbol for dimension that we just did in our flashcards?
D.
D. Yep. So where do we see the dimensions written out on our chart here? You see the row that says negative 1D, 0D, 1D. So all of those D's stand. You see the minus sign in front of the one? All of those D's stand for dimension. All right. What do we notice about the numbers? Starting on the left. Let's attend to these.
Negative 1,
And then as we move farther right,
2, 3, 4.
what happens? As we move farther right with the numbers, what happens? Yeah, the numbers get higher, right? So let's think about as the numbers get higher, let's look at our reference row. What's happening? We start with a point, right? And then when we get to 1D, we get to a line. And then when 2D, we're going 2 different directions, right? 3D is space. Good job. And 40 is called tesseract. You say that? Tesseract. Good. Then we see our vectors. Hey, this is cool because we talked about this earlier this week. A point has what linear meg? No length, no width, no height. So you see right there that that box is X'd out because it doesn't have any of those properties, right? All right, good deal. Go ahead and turn to page 9 for me. I'm sorry. So this is when it does have length and width. So 0 dimension is a point, has no length with a height. But then when you get to 1 dimension, you have just length. Then when you go to the 2nd dimension, you have length and width. So it builds and it gets bigger, right? Yes, go ahead and we discuss their connection, right? So to attend, the A stands for attend, we attend to the hidden zeros and ones. Like in these formulas right here, right? So anything, right here we have 2x to the 0 power, and we talked about anything to the 0 power is, anything to the 0 power equals what? Equals 1. Anything to the 0 power equals 1. So that 2x to the 0 power right there is a hidden 2 times 1. No, we're not writing, we're just attending, we're paying attention. Yes.
Color in the box or
I prefer doing check marks, but it's your book and you can do whatever you want.
I do that, they do that.
That's fine. Okay, so we have NAM in name stands for memorizing the laws of 0 for each operation, which we talked about way right here. We talked about memorizing the laws for 0 in each operation. I think it was back on day 1.
Mom,
Yep.
I see something. That says name, but that also says name.
It does. So it's an acronym. An acronym means we took the first letter of each word and we made a new word with it to help us remember all the steps. So the naming, attending, memorizing, E stands for expressing. 0 is important because it holds place value.
0 means nothing.
It does mean nothing, but remember how we talked about it yesterday? If I write 2 1s on the board,
That'd be 2.
if I write 1 and 1, which one of these is 10? We need a 0. So even though 0 means nothing, it can hold a place so that our numbers are actually different, right? It's holding that 1's place value so that the new 1 is pushed up to the 10's place. And it makes it be a different number. Alright, and then our S is for storytelling. We look at the cover art and we read the contribution to the conversation. And what did we say we thought jurors, angels were thinking about?
Nothing. Sadness.
Yeah.
It looked like nothing and sadness.
Because melancholia means sad.
That is one of the definitions for it, yeah. We talked about from the contribution to the conversation. Hold on 1 second for me. We talked in one of the contributions to the conversation paragraphs was talking about how maybe the angels are wondering about how God made everything from nothing when they have all of those tools in the picture, right? Okay, looking at page 10, middle section. Classicalists train themselves to think by using the 5 common topics. This is more of our essentials and challenge stage. Definition, comparison, relationship, circumstance, and testimony. On page 3, 0 was defined. On page 8, unusual circumstances for using 0 were identified. So let's compare 0 to any other number. If you are in first dimension and can use a number line, is it possible to say that 1 is greater than 0? You see right here where we are with the number line? So if we are in the first dimension and we have a number line, can we say that 1 is greater than 0?
Yes.
Yes, it is. 1 is greater than 0. Yes, in first dimension. So
Second dimension.
it would still be greater than 0. In 0 dimension, though, the first dimension line vanishes. The numbers remain with no way to compare them. So the idea is that of greater and less than disappear when our number line disappears. We don't have that option in 0D, right?
Dimension.
Yes.
Dimension.
Good job. So the ability to compare ideas grows as more dimensions are added and is limited as dimensions are removed. In negative 1D, where do numbers go? So think about it on our number line, yeah?
Yeah.
If we have, go back to memory and invention page that we just looked at. In 0D, we can't compare numbers because it's just a point, there's no line, right? What happens when we go to negative 1D? There's nothing. The numbers disappear. It's not even an option, right? It's kind of fun. All right, look at the, oh, sorry. Yes,
What's the other thing we were
in 0D, it's just a point. In 1D, it's a line. But if we go to negative 1D, cartoon on the bottom of page 10. This is an example from the math journal, Seeing the Unseen for week 29. Somebody said, a story is told inside two similar polygons. Both of these polygons are squares. Can you make out what the cartoon says?
I can't find your sister anywhere. Plus a whole bunch of stamps, a large box, and some twins.
Twine. I think that's neat. Twine is a type of string. All right, turn the page. 11. Twine is a type of string, usually a rougher material. Yes, when we finish page 12, we'll be done for today. All right, looking at the middle of page 11, relationship, how things relate to each other, is another common topic. So consider how operations can be used to relate 0 and 1. Look at this first question, is 1 plus 0 1?
Yes.
Yes. Can you write yes there?
Yes.
After the question mark. Right here. Is 1 plus 0 1 equal to 1? Okay. Hey, will you please do in pencil or an erasable pen just in case we make a mistake we can erase it? Thank you. All right. You can highlight with highlighters, yes, but let's make it. That's okay. It is backwards. All right. Look at the next one. Is 0 plus 1 equal to 1?
Yes.
Yes, because the identity law for addition states A plus B equals B plus A, right? Okay, so this one is yes as well. Now, here's your next question. Is 0 times 1 equal to 1?
No.
No. Anytime we multiply by 0, we have 0 groups. Now, is 0 divided by 0 equal to 1?
No.
No.
Was I supposed to do that?
Yeah, that's correct.
So
right here we have is, oh, you already got that one. And then the last one says, is 0 to the 0 power equal to 1?
Yes, because anything to the 0 power is 1.
I tried to trick you, but you caught it. So 0 divided by 0 is not equal to 1.
That was like 4 years.
0 to the 0 power equals 1.
Is that yes?
Is it?
Yes.
Yes.
Try to keep the yes.
Yes. Because anything to the 0 power, even 0, is 1. All right, so as we relate 0 to 1 using different operations, operations is, are we adding, subtracting, multiplying, dividing, we begin to understand their relationship as more than just less than or greater than. The laws of arithmetic describe the relationship between numbers. Here we go. We're going to read our identity law of addition. Says A plus 0 equals A. Mason, what is the inverse law for addition? A minus A. A minus A equals 0. Good. Then our 0 product law is if A times B equals 0, then either A equals 0 or B equals 0 or both are 0. Because anytime we multiply by 0, it's a 0. So we did that. No, we don't write numbers next to that one. Okay, these are just rules that will help us when we're dealing with our numbers to make them do what we want. Property of 0 equals any number divided by 0 is undefined or infinite. And 0 in exponents, Ayla, tell me about that.
B to the 0 power equals 1, comma, log, base, 1 equals 0, comma,
The 0 square root.
the 0 square root of 1 equals B or any other number, thus called intermediate.
Indeterminate.
Indeterminate.
Can't determine it. All right, look at page 12, center section. The last common topic that we're going to explore with 0 is testimony, or sometimes called authority. We are going to answer using our 5 common topics. How do you know what 0 means?
Because it's nothing.
How do you know? Who told you? Who told number 0 when we do math. Before calculators, 1 divided by 0 was defined in trigonometry books as infinity. Do you see this little sideways 8 right here?
Yes.
That
It's
is
called
the
infinity.
infinity symbol right here. Okay. Now, 1 divided by 0 is called an error due to calculators. Trying to divide 1 by 0 on your calculator gives an error message. A human can understand infinity, but a calculator cannot. Give me 1 second, we're almost done. So true for first dimension arithmetic, 1 divided by 0 is undefined. True in describing vertical slopes in second dimension geometry, 1 divided by 0 is infinite. Our answers can change in